is Miss Israel, and this is going to be our first video in Unit 2. So we're going to start Unit 2, Topic 1, and this is question 20 from the Algebra 1A exam review packet. All right, Topic 1 dealt with what is a function or a relation, and how do we relate two variables to each other. And we learned about function notation, we learned how to write functions and use them to answer questions. All sorts of properties and characteristics of functions. So that's what our questions are going to be dealing with in Unit 2, Topic 1. Okay, let's start question 20. The graph below shows the price of pizza with up to 4 toppings. Notice they underline that up to 4. That must be pretty important. I'm going to underline it too. So you cannot have any more than 4 toppings. All right, and we have a graph here. And I think a lot of times we tend to just skip over the graph, but let's really look and see what we have going on here. On our horizontal axis, we're dealing with the number of toppings. On our vertical axis, we're dealing with the price of the pizza. So the number of toppings increases, the price is going to increase. And notice our variables here, they've given us an n on this graph and p of n. So how this reads, p of n. Okay, that's function notation. Okay. And we've got how many? 1, 2, 3, 4, 5 points on our graph. So let's look at our questions. A, relate the variables using the expression is a function of. So what we want to decide is which one of these variables is going to be independent and which one is going to be dependent. The independent variable is the one that's in control. Okay. And my hint to you is that the independent variable is always be on the horizontal axis. So we already know that n is our independent variable, which means that our dependent variable not spell that correctly, dependent variable has to be p. Nice, so we know our independent variable is going to be the number of toppings and our dependent variable is the price. So the other thing I like to say, we know then that the price depends on the number of toppings. That's just another way to describe the function. And so we're actually going to use the sentence, the price depends on the number of toppings for part A. But instead of the depends on, we're just going to put is a function on. So if the price depends on the number of toppings, then the price is a function of the number of toppings. We have to input a number of toppings in order to decide the output or the price of the pizza. Makes sense. Okay, use function notation to describe the point. Remember our function notation, when we go back up here, was that p of n. So there's our function notation. So what we're going to do, we know we have this function p of n. Okay, and so we're going to use that function notation to describe the point 1250. So think about that as n and p. We have the number of toppings and the price. The way I'm going to say is that we know that p of 2, right, the number of toppings being our input value, is equal to $12.50, or the price, and that's function notation. Okay, the domain of the function is going to be our independent variable, which we already figured out, or our input variable, n. Okay, so the domain is n, but we want to describe that numerically. I'm going to do this two ways. The first thing I want to do is just write it out in words. So what are our possible choices? Well, we know that we can have up to 4 toppings. And if you look at the points on the graph, we have a price for 0 toppings. We have a price for 1 topping, a price for 2 toppings, a price for 3 toppings, and a price for 4. We don't really have 1.5 toppings or 2.5 toppings. We can sometimes do that, but for this question, we're just going to use those whole numbers. So in this case, our domain is going to be represented by the possibilities 0, 1, 2, 3, and 4. So I'm just going to list them out there. All right, do these points describe a linear function? Why or why not? Okay, well, linear function is a line, and if you notice, if I tried to put a line through these points, so starting here, it's not going to be a straight line. There's no straight line that's going to hit all of those points. So this is, in fact, not a linear function. Linear functions have to have a constant rate of change, and so ours is not increasing in that manner. We're going to say not a linear function. The price does not increase at a constant rate. Okay. What is the range of the function? The range is going to be our dependent variable, or the price, right? So the price is going to depend on the number of toppings. So what's the lowest price we have? Well, $10.75, and then we have $11.75, $12.50, $13, and finally $13.25. And here's the thing about domain and range. They're a team, they're a pair. So my price has to match the number of toppings. So I'm going to come up with a price for each of those. So we said at 0, the cost was $10.75. I'm going to keep scrolling up, I apologize. For 1 topping, it was $11.75. For 2 toppings, the cost was $12.50. For 3 toppings, it was $13, and finally, for 4 toppings, we had $13.25. And notice that each of our values in the domain and range are going to match up. So you want those two things to match. If we made a table for this function, we would see that the number of toppings, 0, 1, 2, 3, 4, each had a match in their range values, 1075, 1175, 1250, 13, and 1325. So one hint when you're looking for domain and range on your exam, you could always make a table of values, and that can help you out if you're a little unsure there. And I believe that is the end of question 20.